In this video, we'll talk about intersections on or inside a circle. So a secant line is a line that intersects a circle in exactly 2 points. So lines J and K here are secants of circle C. When two secants happen to intersect inside the circle, then the angles formed are related to the arcs they intercept. So in this example down here, see our secants intersect inside the circle, it tells us this theorem. If two secants or chords intersect in the interior of a circle, the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So what that means is if we're looking at the vertical angle here, then its arcs that are intercepted by that angle would be AB and DC. So the measure of this angle is going to be 1/2 the measure of AB and CD. And then our other angle, vertical angle here, which is the same as this one, this angle, they intercept these arcs. So if we add the two arcs together and divide by 2, we'll get the measure of the vertical angle, or angle 2. So let's take a look at the proof for this. So given HK and JL intersect at M, we want to prove that angle 1, the vertical angle, is equal to 1/2 of JH plus LK. So if we want to prove this, first we know that they intersect at M, that's our given. And then if we look at this triangle here, we have two angles. We have MJK and MKJ that are interior angles, and then our angle 1 becomes the exterior angle. So we can say that angle 1 is equal to MJK plus MKJ by our exterior angle theorem. We also know that the measure of an inscribed angle equals 1/2 the measure of the intercepted arc. So the measure of this angle right here is going to be 1/2 of HJ, the intercepted arc. And the measure of this angle right here is going to be 1/2 of the measure of its intercepted arc. So we have our angle here, angle 1 is going to be the sum of this arc and this arc divided by 2 by substitution. So let's go ahead and apply this to a couple examples. So our first example tells us to find x. We have x right here. So let me zoom in a little bit for you. So if we want to find x, we know that our vertical angle is going to be, so our vertical angle is x, and it equals 1/2 of the arcs that the vertical angle intercepts. So this vertical angle, which is the same as this one, intercepts this arc, RS, and TU. So 1/2 of 130 plus 84. So if we do 1/2 of 80 plus 130 plus 84, we get 1/2 of 214 equals 107. So next one, we'll basically do the same way, but first we have to find this angle here, AEB, because we have our arcs that it intercepts, and then we can solve for x. So we know AEB is equal to 1/2 of 75 plus 143. So 1/2 of 218 equals 109. So this angle here is 109. Now these two angles form a line, so they're supplementary. So they're going to add to 180. So x equals 180 minus 109, which gives us x equals 71. All right, and this last one is just working backwards. We have the vertical angle this time. So our vertical angle is 110, and then the angles it intercepts, or the arcs that it intercepts, are GH and KJ. So our vertical angle is going to equal 1/2 of the arcs that it intercepts. So x plus 97, we multiply both sides by 2, we get 220. This goes away, so we have 220 equals x plus 97 minus 97 on both sides. We get x equals 123.